Okay, so now we're going to look at types of objects that allow us to store ordered sets of values, and these are the arrays, and loops, which are Python constructs that allow us to iterate through ordered sets of values. Um, so we're going to first look at these array types, how we can extract values from these ordered sets and subsets from these ordered sets. And then we're going to look at an example of using restriction or simulating the effects of restriction enzymes on DNA sequences. And we're going to also look at the for loop. So basically, the for loop allows us to iterate through a series of values. Um, the range and enumerate functions can help us work with the for loop, so I'm going to look at those and then see how some examples, lots of examples of functions and processing arrays and so forth. So once again, this will have lots of information, but note that the idea of these lectures is not for you to memorize everything, but for you to have the basis where you can go back to whenever you need to follow through and to review and to help you do these exercises and learn these things at your own pace. So you don't have to remember everything by the end of the lecture. So let's start with lists, tuples, and strings, which we already saw in the previous lecture. So basically, a list is an object that you can use to store an ordered set of other objects, whatever objects you want, but it's mutable, which means that you can change the contents of the list. The list object is always the same object, but you can add elements, remove elements, or replace elements. So this is often used when you need to store sets of values that have the same meaning, the same sort of meaning. For example, different years in a list. And when you need to change the elements or add new elements there. The syntax for creating a list by extension is this square brackets. So you put square brackets at the beginning, you put all the elements you want in the list separated by commas, and then at the end you close the square brackets. A tuple is very similar to a list. It's also an ordered set of objects. You also create it in a similar way, which is begin with parentheses, end with parentheses, and put all the elements separated by commas. But a tuple is not mutable. It does not allow you to remove objects, to put in more objects, to change objects. Once you create the tuple, it stays that way. So this is normally used when you don't need to change anything there, and when the objects have a meaning that depends on position. For example, if you have coordinates x, y, and z, then it would not be a good idea to be able to delete one, because then you don't know what the other two are exactly. So in this case, if you use an immutable object, you have this advantage. There is another advantage which we will see with dictionaries, that you can use immutable objects as keys of dictionaries, but we'll see that later. So basically, lists and tuples are ordered sets of objects, and in the case of list you can add or remove elements. In the case of the tuple, you cannot change anything there. You can index elements of these arrays, or lists, tuples, or strings. Strings are also immutable arrays, but they are arrays of characters, as we saw previously. And you can index them by telling the index of the element that you want. For example, if you have this string, once upon a time, if you ask for the element of index 0, this is O. So Python starts indexing at 0. 0 is the index of the first element. Element of index 1 is n, the second one there, and so forth. So if you have this list of years, you have the same thing. The year of index 2 is this one, the third element on the list. The same for tuples. So if you have this tuple, the coordinate of index 1 is the second one there. So remember, indexing starts at 0. You can also index counting from the end if you use negative integers in the index. So -1 is the last element, -2 is the one before the last element, and so forth. So you can also index arrays from the end. Another thing that we can do with arrays is to slice them. So indexing asks for a single element at a given position. Slicing asks for a subset, another array, that contains a select set of elements. And the generic syntax for the slice is to specify the start, the end, and the step separated by colons. So for example, in this case, we want to start at -5, go all the way to -1, and have a step of 1. So if we have this number, the slicing point at -5 is here, between 0 and 1. The slicing point at -1 is here, between 4 and 5. And if we have a step of 1, we want everything here. The step tells you how many you will skip. So if you give a step of 2, for example, you get every other element. For example, here we have from numbers, we don't give the beginning, the start, and we don't give the end. We just put the 2 colon signs here. And this means that Python will assume we want to start at the very beginning of the array and end at the end of the array. But we give a step of 2, so it's going to give us 0, then it's going to skip 1 and give us 2, and then it's going to skip 3 and give us 4, and then it's going to skip 5, and that's the end. So it's going to give us 0, 2, and 4. So this way you can specify when to start, when to end. You can specify with the positive or negative indexes. It doesn't matter. The thing you must remember is that the slicing points are between the elements. So for example, the slice point at index 0 or -6 is here before the first element. The slice point at 1 is between the first element and the second element. So this is where you're going to cut to slice the array. Note that don't try to memorize this. This is difficult to memorize, but this is something that you just need to know that you can do this. So if you have an array and you need to slice it in some particular way, you go to the documentation, look up the slides, check on the console how it works, and then you implement it in the appropriate way. So no need for memorizing this. Just remember that this is possible to do. And then when you need to do it, look up the examples and the documentation to see exactly how to do it. And that is the general approach to programming. If you know that something can be done, and if you have a general idea how to approach it, you can go on Google and see the exact recipe easily. What you cannot do is, if you don't even know that it can be done in that way, then no amount of Googling will help you in that case. You can also use a negative step. And so you can skip from the end to the beginning, and if you use a negative step, you will reverse the order of your set, so of the array that you get as a result. So for example, I can start at -3, go all the way to the beginning using a step of -1. So I start here at this cutting point, and then I go all the way to the beginning backwards here. This gives me these values in reverse order. So I have all these values, but I start with the last one and then go the one before last and so on. This is a bit confusing because when you use negative steps, the position of the slice points gets a bit changed, because the rule is that the slice points appear always before the corresponding elements. So the slice point 0 appears before the element of index 0. The slice point 1 appears before the element of index 1. So if you're going from the end to the beginning, you find the slice points here. And if you're going from the beginning to the end, you find the slice points in this position. This is a bit confusing again to memorize, but this is just to let you know that you can do this. You can change the order of the array. You can slice in different ways. If you need to implement this in some particular case, look at the documentation, do some experiments just to make sure that you have things right, test your code, and it should be easy to do it. Okay, so the same thing works for strings, tuples, and lists. Only strings are arrays of characters, so you can ask for specific elements, you can slice the string, you can do something like this. For example, if I want everything from the end to the beginning with a direction of -1, I get the string in reverse. So this is a very easy way of obtaining the reverse of any array or a string. You just put 2 colons and -1. This means that I want everything, but with a negative step of -1, so everything gets reversed. You can assign elements to parts of a string. So you can assign values to an element, a slice of a string. For example, if I have this string with these numbers, and I want to replace the numbers from index 1 to 3. So this slice I want to replace with these two numbers. I can do it like this. I can assign to this part of the list these two numbers, and I get this result. I can also put things on the list that are not numbers. So lists can store whatever you want them to store. So you can say that I want to put in that place of the list, for example, these 2 characters. And now these 2 characters get distributed in the same number of elements. So this is a general thing that Python can do, which is unpacking an array of elements into the same number of places, of containers where you can put them. For example, I have 2 variables here, and I want to unpack these 2 numbers from slice point 3 to 5. I want to unpack them into these 2 variables. So these numbers 3 and 4 will now be distributed, will be unpacked into variables a and b. So a will get the number 3, b will get the number 4. And you can do this in general. For example, I have a tuple here which has the first element is 1, the second element is a string, the first element is a list. If I unpack this into a, b, c, then a will get the value 1, b will get the string, which is the second element here, and c will get the list. So you can do this unpacking and distribute the elements of an array through variables. You can also do this with arguments in functions by adding this star sign here before the array. So this is something that often you won't use, but there are some specific situations where it may be practical to use, and especially you may find this if you Google something about Python and you want to find some solution for a problem. You may find this sort of thing. So it's good at least to have an idea that this exists. Suppose we have this basic function we saw in the previous lecture for adding 2 values, and we call it with a tuple with the 2 values. Now, since this tuple is only one thing, one object, it will be put on the a parameter, and there is nothing for the b parameter. So we get an error. We have this b parameter here, so we need an argument for b, a value for b, and we are not providing this argument. But if we put this star here before the tuple, we are telling Python to unpack the elements of this array into the parameters of the function. So Python will put this 6 on the first parameter a, the 9 on the second parameter b, and this now will work and give us the correct solution. So if we have the values for a function in an array, we can just put the star there. Usually you will not do this. I will not show examples with this, but you may stumble upon this when looking at something on the internet or something like that. So at least when that happens, you can remember that you saw this explained in some slide, and then go look it up. Okay, so lists have lots of useful methods because they allow us to do things with the arrays we have there. So we can start with a list. We can add elements at the end of the list using append. So this will add whatever we put here will be added to the end of the list. We can also use extend, where if we give an array of elements to extend, extend will put each element of this array into our list one at a time. So this is different from append. Append puts everything as one element on the list. Extend will put each element individually, so you can extend a list with another list, for example, or a tuple or something like that. You can find the index of the first value given here on this index function. So this method of the list will look for this value and give you the index of the first time it found this value. You can remove elements from the list by value. You can reverse the list and so on. So remove parts of the list and so forth. So you have many ways of manipulating the elements that you have stored in the list and the list itself. We saw some useful methods for strings, so things like upper, lower. You also have index. You can put a substring there and see if you find it in the where you find it on the string. You can count how many times some string appears. You can split a string based on some substring. For example, split with t, it will delete the character t and give you a list with the fragments. So it gives you pi and han and remove the t. So you can use this if you have a string that contains several elements separated by some character. So this is, again, just a general idea that you have lots of methods for doing things with strings. So if you want to do something to a list, to a string, you can Google the kind of thing that you want to do, and usually it's easy to find a solution, or you can look up the documentation or some examples that I have here. Okay, so one important thing that we have to take care when using mutable objects in functions. We saw previously that functions have their own namespace. So the names that you have in the function do not interfere with the names that we have outside the function, because the names exist in different universes. However, if you have a mutable object, both inside and outside the function, you can have a reference to the same object. In fact, this can happen whenever you use attribution. For example, when I do this, a equals to the list 1, 2, 3, the interpreter will create the variable a, this name, and in the corresponding address will put the list in some binary code, but it has this object there. If I do b equals a, then the interpreter will create the variable b and make it point to the same object as a. So now a and b are synonyms to the same object there. If this object could not be changed, it would not make a difference. It doesn't matter if it's the same or different, because it's always, say, 23 or some given string, something like that. But if it's a mutable object like a list, then this effect may happen. If I create the list and assign a to that object, and then assign b to the same object as a and b are pointing to the same object. So if I append the number 4 to the object referred to by b, b will have a list that has 1, 2, 3 and 4 at the end, but a will also have a 4 at the end, because a and b are pointing to the same object, and it was the object itself that changed. So you must remember that when you're using mutable objects, take care that you may have several references to the same object. And this can happen inside functions too. For example, this function receives a list and a number and uses the append method to append a number to the list. And then it puts on the a-list variable a new list that is empty. What happens if we start with the list 1, 2, 3 and then call the add to list with this list elements to add 22? What happens in this case is that elements will now have 22 added, because in this line, this variable, a list, was referring to the same object as this variable element. So a list and elements are names that are living in different universes, because one is inside the function, the other is outside, but they are both pointing to the same list in memory. So if it's the same list in memory, when you execute the append method of that list object, then the list changes in memory. When we do this, it doesn't change the list, because what we're doing here is pointing the A-list variable to a different list that we created, an empty list. By the way, this is the way you can create a list without elements if you want then to add one element at a time. So this doesn't change elements here, because this only points the name A-list to a different object. But this changes what we see in elements here, because it's calling the append method of the object pointed to by A-list, and this object is the same as the object pointed to by elements. So this may be a bit confusing at first, and usually you will not find this problem if you take care not to change mutable objects that you receive as arguments in your functions. But if you do want to change them, remember that different names may be pointing to the same list or the same mutable object, and if they cause that object to change, then this effect will be seen by all the different names. Okay, so let's see an example of how to use these lists and how to use the string methods and so forth. So this enzyme here, BSRG1, recognizes this sequence in genes. So TGT-ACA is a recognition region of this enzyme, and this enzyme will cut here between the G and the T. So this happens when you have DNA in solution, you put in the enzyme and it will cut specifically at that place. And now we're going to simulate this. We'll start by having this string with the DNA. Note that this is just one string, so I could write it like this, but it wouldn't fit the slide, so I put it this way. And this is a trick that you can use if you want to break down very long lines, which is to use this backslash that tells Python that the next line is to be interpreted as the continuation of this same line. Since I cannot break inside the string, I can concatenate these two parts and generate a single string. And now this is my sequence that I'm going to cut. I store in this variable the recognition region of the enzyme, and then I can just split the string whenever it finds the recognition sequence. So since this TGT-ACA appears in some parts on my string, when I do split, I break the string into different fragments. Now, one problem of using this is a simple approach. I'm just using the split method and breaking down wherever the enzyme recognizes the cutting point in the DNA. But one problem is that I'm losing the recognition region, because all this part, whenever the enzyme finds a sequence like this, TGT-ACA, it will remove. So the split method, unlike the enzyme, will completely remove this part, while the enzyme would only cut between the T and the G. So instead of simulating what I have here, cut between this T and G, I am just deleting all the recognition point. So this is not correct. But we can improve this a bit. So this is the recognition site. This is where the enzyme will cut in the recognition site, and we can mark the cutting point with this dash there. So there are no dashes in our sequence other than those that we may put to specify where the enzyme will cut. So now we can use a sequence of calls to these methods, and I'm going to create the marked version of the sequence by calling this replace method on the original sequence, and replace all instances of the recognition site with this string that has the cutting point marked. So I get something like this. It's exactly the same sequence, the letters are all there, but now I have these dashes marking where the enzyme would cut. And then I can split the string using the dashes, because the dashes I can throw away. They are not part of the DNA. They are just marking the cutting points. And now I have the correct fragments here instead of the fragments with parts missing as I did before when I just deleted the recognition site. So this is an example of how you can combine these elements. And now we can write a function. We can write a function to digest, do the simulation of digesting a sequence with an enzyme that has this recognition site and this cutting point inside the recognition site. So we create the marked version of the sequence by replacing the recognition site with the cutting with the string that has the cut point marked. Then we get the fragments by splitting on this dash mark and return the fragments. So this is basically the same thing we've been experimenting here, but this illustrates an important point in functions. When you write a function, you are writing a generic recipe. Note that there is nothing here in the function that specifies what the sequence here, what the recognition site here, where the cutting point is. All of these are obtained as input. The function only specifies what to do with that input to produce the correct result that we want. So regardless of the input we give, as long as the input is the kind of things that the function is expecting, we get correct results. So how do we use this function now? We create the input for the function. So in this case, the recognition size, the recognition site with the marked place of the cutting point and the sequence, and we call the function giving this input. If the input was different, then the result would be different, but the function is always the same. So this is one important feature of functions. You generalize the recipe and you can reuse it for whatever set of values that you want to process in any particular case. And now we obtain here in this fragments variable the list of fragments, and we can access each fragment. For example, this is the first fragment, the second fragment, the third fragment, and we can ask what is the length of each fragment. So the length of the first element of the list fragment is 24. So the first fragment of our DNA after digestion has 24 bases. And then the other one 32, 24, and so on. But this is not a very practical way of using these results, because if we had a digestion into, say, 200 fragments of a very large DNA sequence, then we would have to type quite a lot of things just to get this information. So what could be really useful is a way to go through all these fragments one by one and extract whatever data we need. So this is what we can do with the for loop. To build a for loop in Python, you use this syntax here: for some variable in something that can be iterated, something that you can loop through, and then a colon, and here whatever you want to do at each step. And each step of the loop, so each time this code block is executed, the variable you put here will be pointing to one element of whatever you have here that has a series of elements. So an iterable can be a list, a tuple, a string, something like that, that can supply one element at a time. So the basic idea is that whatever you write inside the for loop will be executed once for each element in this iterable, and for each of these steps, the variable you put here will be pointing to that element of the iterable. So let's see a simple example here. Let's say we want to add these values. So we start with a total of 0, and now we take 3 and add to the total, then 5 add to the total, then 7, 1, 2, and we get the total of the values. So to do that, we can create a loop where the variable v, this is a new variable that we created just for the loop, will point in sequence to each one of the values in this list. So this is what we are telling the interpreter here. Use v to point to each element of vals. Then we have a colon and an indentation to indicate that this line is inside the loop. So this is the line that is repeated for every value in vals. And for every value in vals, v will be pointing to that value. So v will first point to 3, and then when the next time this line is run, it will be pointing to 5, and the next time pointing to 7, and so on. So if we do this, if we compute the total plus v, and we store it back in total, note that this may seem strange as an equation, but this is not an equation. This is an assignment. So what you're telling Python is to figure out how much this expression is worth, so what is the result of this expression, and then store that value in this variable. So since total starts at 0, v will point to 3, 0 plus 3 is 3, and now we put the 3 in total. And now total has the value 3. The next time we reach here, so the next step of the loop, v will be pointing to 5, and total will have the previous value 3. So now we have 5 plus 3, 8, and we store it here in total, and we keep doing this until we reach the end of the list. And then we can print the string sum and then the total. Note that this print is back again on the same alignment as for, and not forwards like the total. So if we wrote it like this, print would occur on each step of the for loop. If we do it like this, print will only be executed after the loop ends, which is what we want in this case, because we only want the final sum. So if you run this, you get this result, sum is 18, which is this print here. So let's go back to the enzymes and see how we can use this. We created this function for digesting. We have this sequence and we get these fragments. So now we can, if we want the length of all the fragments, we can just write a for loop. So for frag, this is a new variable in this array of fragments. So remember that fragments is a list with the fragments we obtain by digesting the DNA with that enzyme. So we are iterating through this list. This list has 3 elements, 1, 2, and 3, all these 3 strings. So this loop will iterate through the list, and frag will point to each of the strings. If I want to print the length of all of those strings, I can do inside the loop, print the length of frag. By the way, if you do this on the console, in these ones in yellow, I'm writing on the editor, on the source code editor. If you do this kind of thing on the console, when you type for frag in fragments and a colon, if you press enter, you'll see this prompt here. So Python, the console is waiting for you to finish all the loop before executing it. So you write print len frag, you write enter, it's still waiting for you to finish, but if you write enter again and leave an empty line, this is a signal for the console that you finished typing what you wanted to type, and now it executes the loop. So it's going to run this. It means that frag will go through the 3 elements of fragments, and for each of those, this line will be executed, and you get the length of each fragment. Now suppose we want the length and the index. So we want to know that the first fragment has this length, the second fragment has that length, and so on. One thing that is useful for this, if you want to iterate through the indexes of some array, you can use the range constructor. So I'm calling it a function here in scare quotes, because this is actually, it creates an object, but we can think of it as a function. It's not a problem. This returns an iterable that provides n integers starting at 0. So if you call range with an integer value here, it will give you an iterable that starts at 0 and gives you this number of integers. So in this case, it's 0, 1, 2, 3, 4. And this is exactly the indexes for any array with 5 elements. Remember that indexing starts at 0, so if an array has 5 elements, the indexes of the elements are these, 0, 1, 2, 3, 4. You can also use range more generically by giving the start, the end, and the step, so similar to what we do with slicing. and it will start at this one, end before this one, and skip according to the step that you give. But this is a less used version of range. Usually what we use range for is something like this. I want to iterate through this array, so in this case fragments, but I want to iterate not through the values but the indexes of the array. So I ask for range with the length of the array I want to iterate through. So this tells range how many indexes I need. Range gives me the indexes starting at 0, and now I can do this. I can print the index and the length of the fragment with that index. So in this case, I'm just iterating through the indexes of my array, and I can do this. The fragment of index 0 has a length of 24, index 1, 32, and so on. Another way of doing this, if you need both the element and the index, you can use the enumerate function. The enumerate function will return an iterable that contains the tuples of index and object. So for example, suppose we have this list. This list of things has large, 42, and 3.14, so the value of pi. Has these three elements. If I enumerate this list on a for loop, each pass of the loop, so each iteration, will this variable here x will have a tuple that has as the first element the index and the second element the corresponding element on the list, on the iterable I have here. So enumerate basically gives me as tuples the indexes and the objects together, which can be very useful if I unpack. So if I do this, index and the thing in enumerate all the things, then index will have the index, this ix will have the index, and thing will have the object there. So I print the thing of index ix is this thing here. So thing 0 is large, thing 1 is 42, and so on. So you can use enumerate if you want both the position and the element, and enumerate gives you those two together as a pair that you can unpack here into different variables if you want. Okay, so let's see some quick examples with for loops. Suppose you want to compute the arithmetic mean. We don't actually need this because we have functions that do this, but suppose we want to create a function that returns the mean of an array of values. We start with the total at 0. We loop through all the values. We add to the total, just like we did for the sum, and then we return the total divided by the length of the number of the array values. So length of values is the number of values, and this gives us the mean. Another example, if we want the geometric mean instead of the arithmetic mean, so the arithmetic mean is the sum divided by the total number of elements. The geometric mean is the product raised to 1 over the number of elements, or the nth root of the product of the elements. So in this case, we start at 1. We cannot start at 0 because otherwise we would always have 0. But we do the same thing. We loop through all the values. We multiply the product we have so far by each of the values and store it back in the product. And then we compute the nth root of this, where n is the number of values that we have. So this would be an example for computing the geometric mean. We can use this, for example, for the mean and the standard deviation. So we already have the mean for the values. We did this before. The standard deviation is the square root of, so this is the standard deviation for the sample, not the estimator for the population, but in any case, it's the square root of the sum of the differences between each element and the mean squared divided by the number of elements. So basically, we can encapsulate this into two functions. We create one to compute the standard deviation that receives the values and the pre-computed mean, which we can call mean in this function. It will hide this name that is outside the function, but it's not a problem because here it's an argument that already receives the computed value. And now we can create a function called statistics that receives the values and returns the mean and the standard deviation. So this is how we can compute. The standard deviation receives the values and the pre-computed mean and basically implements this expression here. So we start total at 0 and we add to our total each value minus the mean squared. So this part here, and we are doing this sum with the loop. And now we divide this by the number of elements and we take the square root, which is the same as raising to 0.5. Okay, so now we can test our function to see if it's working well, and we can now use it in the statistics function. So the statistics function first computes the mean of our values and then calls the standard deviation function with the values and the pre-computed mean that we have there. And now we have something that is a bit different. We want to return two values. We want to return the mean and the standard deviation. But this is not a problem. If you just put a comma there, you can separate the different values to return, and the function will return a tuple with all these values. So if you call the function statistics on these values, you get a tuple with the two values here, the mean and the standard deviation. If this is not convenient as a tuple, you can unpack it into different variables. So we have the variable m for the mean and the variable std for the standard deviation, and this will unpack this equals operation here. So this attribution will unpack the two values returned by the function into the two variables we are supplying here. So this is one way you can create a function that returns more than one value and then use it in different variables. This is another example. Let's now create a list with each element of the original list, but raised to the power of 2. So we can start with an empty list, and for each value in the list of values we got, we will append to our initial list that started empty, we will append that value squared. So this will create a list in the same order as the original one with the same number of elements, but one that has each element squared. So if we call squares of 1, 2, 3, 4, 5, we get as output 1, 4, 9, 16, 25, which are all the elements squared there. We can do things that are a bit more sophisticated. For example, the Fibonacci series, we start with these two numbers, 0 and 1. So the first element of the series, f0, is 0. The second element, f1, is 1. And each element n is the sum of the previous two elements. So we can implement this with a for loop. So let's say we want n Fibonacci numbers. We start with the first two. These are always 0 and 1. And now we want to loop until we have the n numbers. So since we want to loop until we have the n numbers and we already start with 2, we only need to loop n minus 2 times. So these are the numbers of iterations we have to do. And now this is a special loop because in this case we only want to repeat this operation n minus 2 times. We don't care what the actual index we have at each of this operation, because we're only using range to get the right number of steps, and it doesn't matter if it's step 3 or step 4 because the expression is always the same. So when you need to use a variable for something but you don't care what the variable is, one way of disabling the warnings you may get on Spider is to use a variable called underscore. So if you just use an underscore there, this is a valid name for a variable, but it's a convention in Python that a variable called underscore is a variable we don't care about. So this will not be used anywhere. It's just there because the for loop requires a variable in that place. And what we're doing here is just repeating n minus 2 times, computing the sum of the last number in our list plus the one before last. So this is one of index minus 1 and index minus 2. And after we get this sum, we append this to the list. So now we are adding. We add 0 to 1, and we append that to the list, and then we are adding 1 to 1, so we append that sum to the list, and so on, and this will give us the Fibonacci series. So this is what we are doing here with this append. So now we can test if we want the first 10 numbers of Fibonacci. We have something like this. This doesn't work well if n is smaller than 2, because we always start with 2. So if we ask for the first Fibonacci, for one Fibonacci number, we get 0, 1. We always get 2. So we can solve this a bit by slicing there with n. So this, in the case that this gives us a list that is longer than it should, we just cut it off at n, and so this works for 1, it works for 0. It sometimes doesn't work, because if you use -1, then a -1 there is the one before last, and it gets strange. But okay, for this kind of purposes, we can expect that people will not ask us for a negative number of Fibonacci numbers, because that would not make much sense. So this is an example of a loop where we don't care about what we are iterating with. We just care about the number of iterations. So we do something like this. For I don't care in range n-2, do this, because I just want to do this n-2 times, and I don't care in which position I am at the loop at any of these times. So there are two ways of adding elements to the list, with append and extend, and the difference between them is that append will add the argument you give as a single element. So if I have this list with a 0 and I append ABC, then the list gets ABC there. But if I extend with ABC, extend will iterate through all the elements of the argument and put them in the list one by one. So I have A and B and C. So if I extend by 1 to 3, for example, I get 1, 2, 3, instead of, if I use the append, I would get something like this. I would get 1 to 3 as an element of the list, and not as 3 different elements. So you don't need to memorize this difference right away, but just remember that there are different ways of putting elements at the end of a list, and you can then look up the documentation if you need. Okay, so let's go. I'm going to go a bit quickly over this example, but the idea is that then you can follow this more at your own pace by using these lectures as a tutorial that you can go through, and you see the results, and then you can check with the lecture if you are implementing things right. So let's say we have this text. This is from the Portugal entry in Wikipedia, and we want to count the length of the word. So words are separated by things like commas, line changes, spaces, and so on. And what we want at the end is a list with all the lengths. So Portugal has 8 characters, Oficialmente has 12 characters, and so on. So we want to count the sizes of all these words. So first, we know that we can take advantage of this, that if we use split with no arguments or with none as an argument, it will split on everything that is a white space. So it can be a change in line, so changing from one line to the next, or a tab character, or a series of spaces, or one space. It doesn't matter. It just removes all the white space and splits all the words according to that white space. So none is useful so that we don't have to take into account that words can be separated by new lines, by space, tabs, and things like that. Everything that is white space, or these things that are invisible in the text, if we use none as an argument of split, it will cut there. So the idea here, the basic algorithm that we're going to do is to break the text on each separator, for example, on the commas using split, and then on the periods, and then on spaces and things like that. And we keep doing this through all the separators until we break everything down only into words. Once we have a list of words, the last separator can be the none, just to take away the spaces. But once we have a list of words, we can loop through all the words and get the length of fragments. So the purpose of this example is to show you an example of how to decompose the program and try the problem and try to program it in different solutions, in different solutions to sub-problems that will be the functions we're going to write. So let's start with the main function. We want a function called text word length that receives a text, something like this, and outputs this result, the length of all the words in the text. So this is the main function, but it's hard to do this function all in one go. We have to do several different things, so we can start thinking about how to split this function into different parts. And we can think of the first part will be to split the text into all the different words. And once we have all the different words, we have another function that returns the length of all the different words. So it receives a list with all the different words and returns a list with all the length. This one should be easy to do. It's something similar to what we did with the fragments, just looping through the strings and giving the length. And now we have to think about how to do this one. How are we going to split the text over all the separators? This is not trivial because the split function can only take one separator at a time. So we can do this into different functions. So we have a function that splits the text into all separators, but we create another function that takes a list of strings and splits all those strings with only one separator. This should be easy because this is only a loop through all the strings, and for each one of them use the split with that separator, break it into fragments, and keep adding everything to the list. Once we have this function, we can now loop through all the separators and call this function for each separator. So this one can loop through all the separators and break down the text for each separator. So this is the general layout of our program. Note that I didn't start to implement any function yet. I'm only thinking about what each function will do and how to put things together. So I have this function that outputs the length of all the words. This one will work by first splitting the text into all the words with this function and then counting the length of the words with this function. Now I have a problem. I need to split the text but using all the separators, the commas, the new lines, the periods, and so on. I can solve this problem by creating a function that can split everything, a list of strings, using one separator, and then call this function for each separator that I want. Okay, so now we have an idea how to fit things together. We can start implementing. And we're going to start implementing by starting from those functions that don't need any other function. We're going to start with the first one here, split all, which doesn't need anything else. It receives a list of strings and one separator, and we'll break down all the strings in that list. So our result will be an empty string, an empty list first, and then for each string in the list of strings, we're going to split that string by the separator and extend our initial list with all the fragments we obtain. So remember that extend adds all elements individually. And since split returns a list with all the fragments, we are adding all the fragments individually. So now let's test. Suppose that we have a list with these three strings, this one here, and this one here. And we want to split it by this separator, which is the comma. And so we expect that this one will be split, this one won't be changed, and this one will be split twice. And this is what the result we get here. So we built the first function, we tested it to make sure it works. And now we're ready to use this function on the next one. So the next one receives one string, which is the whole text, and all the whole list of separators we want to use. And it will return a list with all the words broken down. So in order to send the text first to our previous function, remember that our previous function is expecting a list of strings, so we can create a list with only one string, which is the whole text. And now for each separator in this list of separators, we are going to call the function split all. This one we wrote here, and this one will split the list that we're giving it, which initially has the whole text, using that separator, and returns the list with everything broken down. So now we replace our list that started with the whole text together, and we replace it by the first result of breaking down using that first separator. So now when we are in the second separator, we are sending to the split all function a list that was already broken with the first separator. So now it's continuing the work and so on until the end. For example, suppose that we have this text that has these special characters here, changing a line, adding a tab. So you can do this in strings. You can add special characters that are not visible by using the backslash. So \t is a tab, a tabulator character. \n is a new line, a line change. So you can put those there. And now we're going to break this down on these separators, the period, the comma, and the none, which will remove all white space. So this is what we get at the end. This text was broken down into the different words that compose it. So things seem to be working, and we can, if you want to see what is happening inside the function, you can add a print there inside the loop. So first we start with a list that has only the original text, and this is sent to the split all function with the first separator, which is the period there. So now result will be a list with the fragments obtained from the initial string by breaking wherever we find the period here. So we have a break there, and so on, and we have this list of fragments. And now it's going to repeat the operation, but using the second separator, the comma, and it's going to be broken down into these parts, and then it's going to repeat the operation using none as the argument for split, which is going to throw away all the white space and give us the final result. Okay, so now we can put this all together by writing the final function we need, which just counts the length of the word. So this is basically create a list by appending to that list the length of each word, and each word is obtained by looping through the list of words and then pointing this variable to each of the strings. So if the words we give this function are these, then the word variable will first point to this A, then to AA, and so on. And these have different lengths that are going to be appended to this list we created here. So now we have the length of all these words that we gave into the function. So again, test your functions, and now we have everything ready to put them all together in the final function. So our final function is actually very simple because it receives a text. It has these separators. We define these separators because this is how we want to break down words: commas, periods, question marks, exclamation marks, and so on. We call the function to split the text on all these separators, and then return the result of counting the length of the words. Okay, so I've been talking for quite a while now. This is a lot of information, but the main idea of these lectures is that now you can use them to check how these elements work, to follow this as a tutorial. So if you want, you can follow the video or follow the lecture notes or the slides and try to work yourselves through these problems. And so we saw here this part of arrays, indexes, the use of mutable objects, the lists. We can add things to the list, replace them, and the for loop to iterate through these sets of objects. So the idea now is that during this week we have the tutorials on Wednesday and Friday, so you can do the exercises there. Look at the PDF I have with the lecture notes and the exercises. It has all the information there. but you can also start, if you're not familiar with programming, and this is very confusing, you can start slowly by going through these lectures on your own and implementing this code. So you have everything here, all the code in the slides and in the videos. So you can implement it, see how it's running, and go through this at your own pace as needed. Okay, so now I'm going to join the Zoom meeting. So if anyone has any questions, we can meet there. So see you soon.